Programming Throwdown, episode 176. MLOps at SwampUp. Take it away, Jason.
All right, folks. So this is going to be a bit of a different episode than folks are used to. I'm actually at the SwampUp conference, which is hosted by JFrog. And, a lot of people, actually probably the number one email or message that we get is, can you explain DevOps, MLOps? Can I get a job in these areas? It seems like a really good, people see it as a really good gateway to, getting into tech. And we get tons of requests for it. And so I had this amazing opportunity to talk to four, different people with very different backgrounds who all kind of ended up in this discipline and can share their stories with us and also explain the technology, explain what DevOps is, explain what MLOps is. And so we're kicking this off with James Morse from Cisco. So thanks for coming on the show, James.
No, thanks for having me.
Cool. So why don't you kind of tell us, actually, let's start off with, what do you do at Cisco? What is your title and what are you responsible for?
Sure. So really my title is technically DevOps engineer, categorized right now under software engineer, which is a perfect segue because of the blurred lines. It's just everybody's, constant battle like you're referring to. But yeah, so DevOps engineer for a team currently called Enterprise DevOps as a Service. So we actually provide DevOps services to other teams within Cisco, try to ease that segue for them, whether they aren't quite on a DevOps path or already are, just need specific services that fall under that umbrella. And
cool.
Just supporting those systems and helping those teams.
Cool. That makes sense. So give us a little bit of your background. Like, how did you get into where you are now?
Sure. Yeah. So I went to Gopher Technical Community College, which is in North Carolina, and got a degree in both computer information systems, sort of general IT degree, all kinds of stuff under that umbrella, server administration, Windows Server, Linux systems. And then also decided on the parallel path for getting the networking technologies degree, which coincidentally was most focused on Cisco hardware. So routing, switching, kind of think of the path for getting like a CCNA certification.
Now, what is CCNA?
Cisco Certified Network Associate. They've kind of floated around either associate or admin. There's a few different, and there's CCNP for professional, different layers, and kind of starts at the bottom. And I think now they've split it into CCIND, but I've long since been in that, so I embarrass myself as an actual Cisco employee now. But yeah, it's the entry level, at least at the time for me, which I did get that degree in the past, was again your basic like setting up routers, switches under Cisco's umbrella. So
makes sense.
To learn how to do subnetting by hand and do it literally on a Sharpie and a dry erase board.
Oh wow,
yeah, I was pretty intimidated, but you learn a lot, and it's still a lot of it still helps me today. Configuring systems and having that understanding of IP communications and setting up different subnets and gateways and stuff.
Cool. And so at some point you were like a system administrator, and then you transitioned to DevOps. So what is the difference there? Like, what's the
so when I first started, I graduated around 2009, and then quickly was placed at a company doing. Title was VoIP support, something along those lines, and it ran the gamut. It was pretty much somewhere between support technician, taking first level calls, but also because it was a smaller company doing what traditional sysadmin work was then. So that was something around the systems were all Linux based. They were CentOS at the time, and on top of that, we had different applications installed for running various things, mostly voice over IP software. So all kinds of system administration at that time, like mostly at that company, it was they were wanting somebody with a Linux background. So Linux sysadmin, typically, and probably still to some degree today, sysadmin work is usually split somewhere between like you're specializing maybe in Linux, Unix, all those types of systems, to the more Windows side, Microsoft Server, those types of things. Obviously now it kind of runs the gamut because you have cloud services and things like that. So you could still technically maybe be system admin or, some type of cloud engineer and not really be, a true DevOps or DevOps engineer. the transition there was, I think, about a year into that company was when I started hearing the buzzwords about cloud. Like the CEO I worked under was very much trying to, keep his finger on the pulse of things and like to be, very bleeding edge as far as any kind of new trends and try to, capitalize on that, help people that were trying to maybe get to the cloud. What did the cloud even mean at the time was sort of, almost the DevOps of now, like people who aren't in the industry hearing cloud. Even now, maybe, you might hit somebody who's not in the industry and kind of get what that means. But I don't rarely run into somebody who's not in the industry who's just like, oh, I know what DevOps is.
Right.
So that was sort of the DevOps term then. It was the buzzword. So that very quickly led into some blurred lines of, what I would consider CI/CD, continuous integration and delivery or some deployment. And that wasn't still true, like what I would call DevOps, but it was starting to go the route of more automation. So less like, okay, I need to deploy something. That might involve, opening up something like it was like WinSCP and then copying some files over at the right time. Okay, we're going to deploy on this, Sunday at some weird hour, 11 p.m. And then copy these files over, maybe restart some services. Hopefully you don't have a lot of those. If you're a smaller company, maybe you have to do that, in some for loop for, hours if you do have a lot. So that transitioned to things like, a lot more scripted stuff. Things like Ansible were starting to come up where you could just, write some playbooks, run those playbooks, and those things would happen automatically. And so that sort of blurred the line for me, at least, in getting into DevOps, where it was more, okay, you've got your code and hopefully a good SCM, something, most famously like GitHub. And maybe I have a branch, something like production or main, something along those lines. I'm working in my feature branch and I get, merged into dev, and that dev eventually maybe gets, reviewed, hopefully gets reviewed by, one or two people and so on until it, maybe is slated to be merged for production. And then in my idea, into a true DevOps, there's at least at some point where you're going to merge that into, your production branch, whatever that's called. And a lot of things are going to start kicking off automatically. So instead of this guy who's just waiting for whatever time, and he's just copying, frantically logging into systems and clicking and dragging, if it's, UI based, you're running for loops and, something like, Linux CLI or terminal. Should be a lot more automated and maybe have some checks and balances. So, if this thing fails, don't do this, and kick off an email, or maybe, a lot of people use Slack or things like we use, being at Cisco, we use WebEx, and maybe it posts into there that something succeeded or it failed. But there shouldn't be a whole lot of manual, if not any, in a really ideal situation, manual intervention or, manual, what some people have deemed click ops, where you're just, in there manually fixing things or changing things.
That makes sense. So would it be fair to say, like, system administration is it fair to say that it's like the part that is left over because it's either not worth automating or you just haven't automated it yet, and DevOps is this automatic tool chain that covers the rest? Is that like the right way to frame it?
Yeah. So and that's why where a lot of people, kind of get into this philosophical argument about, there's so many things that kind of came about around the same time. So when I first started, you could, all the things now that sort of fit together, like DevOps, CI/CD, even agile development, weren't barely even being talked about. They may have some light buzzwords like cloud. Some of those may have been being pursued from an idea, but not with those that phrasing or those terms. And literally within my, career, watch it actually evolve into those things where people are using those terms daily. So a lot of those things in my mind get blurred because they sort of all came out at the same time. Although technically they're completely separate. You could be doing agile for example, but not actually be using any DevOps services. I can't imagine that world. I've never seen it in person. I've seen, maybe DevOps not being used ideally or have some pieces missing that would make it better. Similar to CI/CD, you could be technically doing like infrastructure as code, like something like Ansible, and maybe even doing it with CI/CD or like the Git flow that I was talking about, but not really still be doing all the other parts that come with DevOps. So they don't have to go together, but sort of the complete package in my mind is doing something like using an agile development and then kind of pairing that with CI/CD and DevOps workflows. But in general, the idea is, of course, that you're using like the most common tools for DevOps would be something like GitHub, GitHub Actions, right? So now that merge I was talking about, that's getting kicked off maybe by an Actions workflow, and that Actions workflow just means, like, for example, if I'm using one of the examples earlier, at SwampUp, I think in one of the trains they were using, it's pretty common, Node.js, NPM. So that NPM build might be kicked off actually by Actions. So somebody sitting there actually running all these NPM commands and then, pushing that somewhere, maybe like JFrog Artifactory, and then some system then again pulling that down to be in production. You could do all that manually and be still using those tools. So DevOps isn't just using those tools, right? CI/CD isn't just having that flow. Sort of again, like there's this chart that usually comes out, or visualization rather, where it almost looks like imagine an infinity symbol, where as you have that deployment, you want that immediate feedback. So as soon as you've got a deployment and you're already sort of kind of on the path to the next release, because it's sort of this smooth transition. Right, so that you can have lots of minor iterations and sort of break the barrier that existed when I started with the traditional sysadmin. I rarely talked to any developers, unless there was a problem, right? System's down or whatever. That was sort of the typical MO versus, I just need maybe some change or some help on GitHub Actions. There's a problem, or I need new permissions or something. But if they're given all the right permissions and they've got managements and checks and balances on things like PR reviews and things to get into that automated production workflow, then that's where that DevOps term in my mind kind of comes out, because the developer side, the development side, and operations ops are sort of blended. Because as a developer, even though maybe I don't know too much about like the kind of stuff I used to do, Linux administration and Linux OS, and like how do these files get where they need to be? Do they have executable bits? Like, I'm not worried about all that. I just know that if I merge this PR, into main production, whatever it is, that all these things kick off. And if there's a problem, I don't understand. Maybe I call, DevOps support or, whoever it is. Maybe it's even just a technical lead or somebody that knows like, that error just means this, start a new, feature branch and fix this and try it this way and that.
Yeah.
So
that
kind of takes
sense.
that out of the aspect, at least in that flow. It doesn't mean that nobody's setting up those systems that are running it, because that's kind of where my current role, at Cisco comes in, is like we're, deploying things like we're here at JFrog SwampUp. My main role is managing, deploying, and maintaining Artifactory itself. And that's still, in some cases, on a server. We both have a server in the cloud and all kinds of different deployments. So those still have to get deployed by somebody. But once all those things are kind of interconnected, they allow that continuous workflow for that developer to not have to worry about those things.
Yeah, that totally makes sense. I remember I've seen this through my own career. I mean, I've mostly been kind of on the research side, but I have my wax wings have put me a little bit too close to the sun every now and then. And I have been burned by the production gods every now and then.
As we go.
And in the early days, earlier days of my career, they would, build a new build every week, and it would be a manual process. And there was an IRC channel, and you would just get pinged like, hey, you made this change and this file, doesn't compile, go take care of it. And then it kind of, as you said, it's become more and more automated to where, most companies are just pushing new versions all the time, and they're even automating the failure. So it's like the contingencies are all automated. And so now what you're doing is just orchestrating this self-healing machine, which is really impressive to watch and to be a part of. So now it's, as you said, it's more like you get a Slack notification. Hey, this file that you changed that you is actually being used in this other system you might have not even known about, and it broke it, and so you need to revert it, that kind of thing. But it's very automated now, which is really cool.
Absolutely. I think automation is a huge part of it for sure. And then it's also the sort of the interlinking between those automations, because automations predated DevOps and the terminology there, but I think the true thing is, kind of going back to that infinity loop diagram or visualization, whatever you want to call it, that a lot of people bring up, and I've seen it a couple times even here this year and last year. I was lucky to go to SwampUp last year, and similar, that it's that how they're all intertwined now when they're all playing together well, and then they've been configured right, and you're taking advantage of all the modern features. You really shouldn't have to be doing much unless there's a problem. In a lot of cases now, what has been showcased in both the last year, SwampUp, and this year, a big focus on security. So there's the term now DevSecOps, and several similar type terms, but the idea that somewhere in that flow that we were just talking about, something should be scanning, right? So
right.
Some failure may not actually be that somebody technically did something wrong. They just did something they shouldn't have. Maybe there was a secret in something. Maybe there was an old version used for something. Like going back to that NPM, maybe they used a version that's going to have vulnerability in it. So you want to see that fail. So somewhere in that pipeline, you either have a plugin or some version of, if it's GitHub Actions, maybe there's an Actions for, like JFrog over here, they have their own called Frogbot that has a lot of integration with Artifactory and X-Ray, where it's making sure that those vulnerabilities don't exist, and you can even have it block the pipeline, or maybe just email somebody if it's the type where maybe it's just a development flow. You don't want it to block, but you do want somebody to know, hey, this should not go to production.
That makes sense. What about you have this really expansive background in DevOps, and so how do you see ML ops from your perspective? What is the sort of delta there? What is the part, what's the leap from one to the other?
Yeah, it's a really interesting one, because I've been learning a lot. There's been a lot of focus on that with this SwampUp. So I've learned a lot. The keynote was very good in that. I think they did a good job with their diagrams on literally showing those two differences. So for my background being since I was more sysadmin, like a lot of people, it's interesting, especially with the term. So people come in more from the development side, want to see more operations. So they get into DevOps from that. Obviously, I'm in the other boat, which is people with sysadmin backgrounds or some version of operations getting in. And then, the development side kind of comes in there. So not having much background with the on the ML side or AI, I can at least say that what I've learned already, and even within today's talks, is that there's going to be a lot different workflows. So there's a lot more parts and pieces with everything I was just talking about. You're not just going to have I've got my Git repo, I've got my code, I push it here, it runs some commands, it builds stuff, and eventually, as long as it gets enough actions, or if you're using Jenkins and you've got the right Jenkins plugins, things going to get my app deployed. Not to say that's simple, and to downplay some of the more advanced apps. When you're talking ML ops, there's a lot more at play. Like, am I using a public model from something like Hugging Face? Am I, something being developed in-house completely from scratch? And if I have the resources for that. Obviously, there's so much out there that's a lot less common, but still plenty of people, especially depending on how sensitive the work is going. So there's so many more moving pieces, but I think the idea is still the same. You're just going to see, especially as JFrog is already integrating with some of that, that it shouldn't be as awkward as it was in its infancy, where a lot of that's going to be customized stuff. Like now it should be, again, a very similar workflow, but my short answer would certainly be that there's going to be a lot more pieces there that you're going to have to integrate, like store. And even just from a storage perspective, like the models are a lot larger than just pulling maybe some Python libraries.
Right.
Most people have worked with Python. They've run an import. Doesn't crash your machine. Doesn't fill up their hard drive. Right. Doesn't take many models to fill up at least a modern slim book. That where you might just have 500 gig or something on your hard drive. Maybe 3 or 4 models could easily fill that, if not just one large one.
Yeah.
So now you're thinking, okay, we got to have these properly set up to be stored correctly and optimized. So there's a lot more at play, at the very least, than just a standard DevOps work.
That makes sense. And so we have a lot of folks listening who are just starting their careers. What advice would you give for people? Let's say folks are in high school, or maybe folks who are thinking of going back to college, and they're deciding between that and a coding boot camp or learning on the fly. What advice would you give for young folks who are just getting started if their goal is to get into a DevOps career path?
Yeah, I've seen that question a lot. Even a couple of friends personally have asked that question. So I've given it a lot of thought. I think, depending on what your background is, it's going to really sort of change that answer, at least to some degree. But I think the one common thing is certainly to just don't take for granted the wealth of information that's out there, whether it's, just free resources like YouTube. There's tons of, great videos that teach you all the different pieces of things like, GitHub Actions, Jenkins, just all the different, I wouldn't necessarily get too caught up in, well, I need to master something like a specific language, whether it's Python or whatever, but it's going to take at least the common core understandings of some, programming language and having, the basics of that, because no matter what you're doing, even on the side that I am, where, maintaining something like Artifactory, you're going to have some language, whether it's for scripting or for automation. So having some good basics of that, and then also just, again, taking advantage of all the information that's out there on things like YouTube and Udemy, that are very affordable, very accessible. When I started, you would go find the closest relevant O'Reilly book, right? And and have it by your desk. It wasn't very common to see just a few O'Reilly books or a whole shelf of them, in whatever team's room that you worked in. And you go grab one off the shelf. Not to say that it wasn't available, but that was still sort of the habit. Instead of searching through a trove of maybe like various posts and things like Stack Exchange that, at least early on, it may have been, more difficult than now, especially with things like ChatGPT or anything Gen AI. So don't take for granted the amount that is out there. Just use that to your advantage, and at least learn the those common tools. GitHub and some type of version, something like Actions or Jenkins, that help you automate those things, and just start playing around. A lot of those things right now are free for open source and students and things like that. So you should be able to at least break in at minimal cost, or even free in some cases.
Yeah, totally. Yeah. I use GitHub Actions extensively for a lot of my open source stuff, and they haven't charged me yet, unless there's some mounting bill somewhere that,
right. Yeah.
Unless they get a collections call tomorrow, we'll see. But
so that's the great thing. When you're learning, feel like, don't be frustrated when you break things. Part of it is see how you can break it, break it different ways, and learn how those, broken things are solved, and how you can, change ways to keep the automation going, even if it hits, something that's not critical. Maybe it was meant to, continue on with whatever. And that's sort of the idea. Don't get frustrated at things failing. Figure it out, use that as a learning opportunity, basically.
Yeah, definitely. Yeah, this is great. So I think, one common thread that we've talked about on the show that we're just double clicking on here is build cool stuff. That's basically the short of it. If you build awesome stuff, you're going to have to maintain it. I guess that's one thing with DevOps is, I guess you'll have to build something for other people, or build something where you need to have a process. But even if you don't, you're still going to get a great experience as a developer, and that will catapult you into a DevOps career somewhere. So
yeah, absolutely.
Cool. Hey, James, I know you have to rush. Thank you so much for taking the time to talk to us. I really appreciate it. And if I get any questions for you from the audience, I'll shoot you an email.
Yeah, always happy to help. And it was great being here, and appreciate it having me.
Cool. Thanks a lot. Hey, everybody. So we are here at SwampUp with Luke Marsden, who's the CEO of Helix ML. Thanks for coming on the show, Luke.
It's great to be here.
Cool. So why don't you give people a little bit of a background into how you kind of arrived into starting Helix ML, and what's your kind of backstory?
Yeah, absolutely. So I'm a startup guy. I've been doing startups my whole life. This is startup number 3. Back when I was 15, I started a web hosting company.
Wow.
And I then went and did computer science at Oxford. And out of the back of that experience, I was really inspired to try and solve some of the practical problems we had in the web hosting company. And I did that by building a distributed web cluster. And then that evolved into, we ended up pivoting that business into solving storage for Docker, because when Docker exploded, we were like, we already have all of this tech for dealing with stateful containers because we were using FreeBSD jails. And so we just applied that technology to Docker.
Well, let's dive into a little bit.
Yeah.
So we have a lot of high school folks listening in. So 15 years old, start a company. How does that work? How do you go to somebody and say, I will build this website for you, and you should write me a check? Did your parents help you with that, or did you how do you do that as a high school student?
Well, I mean, I had a co-founder who I met online on IRC, and that's the old school way that we used to communicate back in 2001.
I used to love IRC. It was great. I mean, I guess now it would be Discord, right?
Yes,
that
exactly.
was the Discord of our era.
Yeah, exactly. We just decided together to put together a web hosting company. And the amazing thing about that was that we were just able to put it online, put the website up there, and start telling people about it, and people showed up. And
wow.
One really fun thing happened that helped us a lot with that business was, I've forgotten what it's called, but there's this old Perl based blogging framework. And the guy who created that blogging framework found our web hosting service, and then he left his company and then he said, "I'm really happy with my hosting service," in front of all of his audience. And so we got a nice boost in traffic from that.
That's amazing.
Yeah. Yeah, it was very lucky.
I don't know if I've ever told this on the show, but I did a lot in high school as well. And one of the things I built was a little isometric game engine.
Oh, yeah.
And at the time, there weren't a lot of game engines. This was 1997 or something. Mm-hmm. And so there wasn't a lot of Java, really anything.
Yeah.
And so it got picked up in a book and it got popular. And I wonder if people can just build things and get them noticed, or if that time has passed. I feel like now you probably need to do a little bit more promotion. There's just so much content out there now.
I mean, I think that's true, but I think if you have a passion for solving a problem, then give it a go. And if anything, there's probably more ways of getting the word out these days. I mean, we didn't have YouTube back then. We didn't have Discord communities. I think
that's true.
And more people are online now than were then. So
another thing is the Vanguard has moved. Mm-hmm. So in other words, if you want to make a Java game engine, I'm sorry, it's just there's too many of them. Yeah. But there's a Hugging Face LLM leaderboard.
Yes.
And if you and there's a variety of them, so you might end up with some passion and some talent, you might win the Greek LLM leaderboard. You could reach the top or something. So absolutely.
So shall I continue my story? I mean, we did the storage for we pivoted that business hybrid cluster into Cluster HQ, which was solving storage for Docker, and then we got involved in the very early Docker and Kubernetes days, back before people really knew how to make containers work with databases and other stateful services. Mm-hmm. So at that point, we raised $15 million just by walking up and down Sand Hill Road and saying Docker and storage in the same sentence.
Now, what is Sand Hill Road?
So it's a road in Palo Alto where a lot of the VCs live or work. So there's a large concentration of venture capitalists.
Very cool. I mean, was that intimidating? I mean, that sounds just like an extraordinary amount of money and responsibility.
It was intimidating. It was interesting, and I think I learned a lot from that experience. I think the biggest thing I learned was that even if you have a large Series A, you need to be really, really thoughtful about not growing the company too quickly before you really, truly have product market fit. And so, that was one of the lessons learned. We grew the team quite quickly, and it was challenging. But then beyond that first company, I then had another go. We built we started out with this idea of versioning for development environments.
Okay.
So a lot of my career I've spent like trying to find commercial applications of ZFS, which is a very clever bit of file system technology that came out of Sun Microsystems and then got ported to Linux.
Yep.
And so that attempt of commercializing ZFS was, well, if you've got a development environment and you manage to reproduce an interesting bug, let's say, on your laptop, then shouldn't you be able to not just do a git commit of the code at the point at which you can find the bug, but also take a snapshot of the local development databases that you have running, so that you could maybe attach a runnable snapshot of that thing to a GitHub issue, and then another developer could just pull it down and like reproduce the bug immediately rather than like having to click around in the UI to get the database into a certain state. Turns out that AI and machine learning had a much bigger data versioning problem than DevOps did and software engineering. And so we ended up pivoting to building out this end-to-end MLOps platform, but with that same idea of versioning your workspace. And so what data scientists like AI and ML people often do, like when they're developing ideas, is they use Jupyter notebooks. But when you're using a Jupyter notebook, it's very hard to keep track of your work very accurately. And even like the order in which you run cells can affect the output and things like that. But what we did was to add this snapshotting of your state before and after you did a run. So if you did anything in the Jupyter notebook that would like train a model, for example, then we'd snapshot before and snapshot after. And then we'd also automatically build up this provenance graph. So you could say like, oh, I created this model from this data, but this data was transformed from this other data using this process. And so you can kind of recursively build up this this tree structure of kind of how you got to that point. That was that company was called Dot Science. That was.
I love that name. Is it like the configs were in the .science folder in your home directory? Is that where the name came from?
It actually got really confusing because people would always put like a period and then science.
Right.
But it was actually DOT. So it was that was a lesson in naming things.
Yeah, Department of Transportation Science. I can see other ways that could get misconstrued. So a lot of people might not know this, but ZFS and BTRFS, BTRFS, they have this amazing property called copy on write. And the way it works is, you've probably done this even for school projects. You might say like, I have a document. Nowadays probably everything's in the cloud, so it's kind of transparent. But you might say like, I have a set of artwork that I'm working on, some digital art, and I'm iterating on it, but I don't want to lose my history. And it doesn't really make sense to create a Git repository. I might not know how to do that. The simplest thing would be just create a folder for each day and just have my, Blender files or my Photoshop files just, copied in each folder. And then that starts to become really expensive because you might have all these other assets and they're just all getting copied every single day.
End up using up all your disk space if you do that.
Exactly. Yeah. ZFS has a genius idea. It's basically reference counting. Mm-hmm. So when you copy a file, ZFS doesn't actually copy it. It just creates a shared pointer between those two files. Now, as soon as you change even one bit of either of those files, then ZFS has to make a copy. But if you don't do that, you can have 100, 1,000, 1 million copies of the file, and it's not going to increase your storage cost linearly like a regular file system. And so, I've always been fascinated by that. I really was intent to install BitROT-FS on my latest computer that I got about a week ago. But it wasn't supported by Grub. There were some other issues. And so it's to your point, like it's still not totally, smooth yet. Yeah. And it's been around for a long time, unfortunately.
Yeah. Well, Ubuntu embraced ZFS on Linux, fortunately. And so you can install Ubuntu with a ZFS root.
Right.
So, I encourage anyone who's brave enough to give that a go, and you can do all these cool things. But we run like my newest company, Helix ML. We run all of the infrastructure for that in a data center in my basement.
Really?
Yeah, because we're bootstrapping the business, so we didn't want to incur a ton of cloud costs. So
that makes sense.
I got a fiber link, and we use ZFS on Linux for all of the production storage for that. And then actually rsync.net, this is an interesting piece of ZFS trivia. Rsync.net has support for, they're a backup provider, but they have support for like ZFS send into rsync.net. And then they provide that as a service. So what that does is it means that you can take a snapshot every day of your production system, and it's an atomic, reliable snapshot that doesn't take up any extra disk space, like you were saying. And then you can just send the difference between that snapshot and the previous day's snapshot over to rsync.net, and it will automatically keep it up to date. So anyway, we've ended up falling down a file system rabbit hole.
No, that's fine. Okay, one last file system question, because it's just burning in my mind. What is the difference? And feel free to just cut me off, it's going to take a rabbit hole turn. But what's the difference between ZFS and BTRFS? Are they totally different things, or are they two people trying to do the same thing?
Well, I like how you describe it as BTRFS.
I think that's what it is, right? Or no?
I think that's a joke.
Oh, really? I thought that was the official.
I think it's called ButterFS.
You are totally calling.
But I think you fell for it.
I have to admit, I've said this on the show multiple times. I am known to be the most gullible person. Different people have their superhero strength and weaknesses. Like, I fall for everything all the time, so I'm not surprised.
Well, no, I mean, I don't mean it in a negative way. I just think it's, I can imagine someone on the internet calling it BTRFS as a joke, because it's like BitRot. And
it's actually, I looked it up. It's BetterFS.
Yes.
That is the official name. Or BTRFS, which probably makes the most sense, yes. Right? Yeah.
Well, I think BitRotFS is actually quite apt, because it's I mean, that project has been plagued with data loss issues, and I've never really trusted it to actually be reliable. Whereas ZFS was engineered at Sun Microsystems like very nicely.
Interesting.
And then I was grateful when I stopped having to run Solaris to use it, because it got ported to FreeBSD, and this is like back in the day when we were doing this web hosting company. But anyway.
Well, that is fascinating. There were licensing issues, right? But I guess it's all cleared up at this point.
Yes. Okay. And I think I'm glad that Mark Shuttleworth at Canonical kind of took a stand on that, and he said, like, we're going to go ahead with this. Our lawyers have cleared it. And that like really cleared the way for a lot of other people to say, like, okay, if it's good enough for Ubuntu, then we can use it.
Nice. That is great. That is Ubuntu's like real like big contribution, is just getting everybody to have faith in the whole ecosystem. I mean. We talked in previous episodes about DevOps. We had a dedicated show about it. We've interviewed some folks about DevOps. For folks who are listening, if you missed the DevOps episode, hit the pause button on this episode, go back, listen to the DevOps episode, because what we're going to talk about now is the delta between DevOps and MLOps. MLOps is much newer. We haven't spent a whole bunch of time on it on the show, but as folks know, AI is becoming, really, really important, and so MLOps itself is also becoming, important by proxy. So what is MLOps, and how does it differ from DevOps?
So if you think of three disciplines, software engineering, just like how you write and develop software, how you test it, how you version it, and you think about DevOps, which is how you do CI/CD for deployment, how you operate that, how you do immutable infrastructure in the cloud and things like that. And then you layer in this third discipline, which is AI/ML, which is like this world of using data to generate models that pull the patterns out of that data and are able to make predictions, right? Mm-hmm. MLOps is the intersection of those three disciplines. So it's the intersection of software, DevOps, and AI/ML.
That makes sense. And so if somebody wants to get started in the field of MLOps, how can they, how do they not get overwhelmed with all three, because all three of those you could spend a lifetime. They're all crafts of their own. I think data science and data engineering is a craft. Software engineering is a craft. AI and making the loss go down is a craft I've spent many years on. So how do people get in that intersection? Is it the kind of job where it's really more of a mid-senior level, or can folks kind of get into that, and what would that look like?
I would say that in order to become an MLOps practitioner, you only need a little bit of all three. So, for example, if on the software side, you learn a bit of Python and you're comfortable with Git, on the DevOps side, you get comfortable with Docker and containerizing things and maybe deploying Docker Compose, maybe push out into Kubernetes. Although I'd say Kubernetes is optional. And then on the AI/ML side, if you just train a linear regression model or something in PyTorch or XGBoost, I mean, that's enough to get you started. And then you can start looking at tools like MLflow, which allow you to keep track of model artifacts and track runs. That was something we were big on in my second company, DotScience, was this idea of run tracking. Deploy one of these models into production using Git, Docker, PyTorch, or whatever, and now you're an MLOps engineer. And then you can take it from there, and there's lots more sophistication and how you scale the systems and so on. But basically, that's what you need. So it might sound intimidating because it's three different disciplines. But yeah, if you just take a little bit of each one, then you can get up and running. And I would shout out to the MLOps community. So MLOps.community is actually a community that we started at the end of DotScience. Actually, right when the pandemic started, our sales pipeline dried up, and we were like, "What are we going to do?" So let's start an open community around MLOps. Right. It's I'd always wanted to do that. We bootstrapped that community from nothing with another tech community called BrizTech in Bristol, where I live in England. And then my colleague Dimitrios took the MLOps community and ran with it. And we're now over 20,000 people on Slack.
Wow.
And we've got a meetup in San Francisco this Thursday, which we're hosting. And there's meetups all over the planet. So it's amazing how these things can evolve.
Wow, that is remarkable.
But there's tons of really great material on MLOps, on the MLOps community. There's a good YouTube. And I'd recommend that as a resource.
Yeah, that is great. I love how you took such a kinesthetic approach to it. I'm right on the same page. I think I'll read the book when I've kind of have something half built and it doesn't work, and it's okay, now it's time to read the manual. I know some people are the opposite. I used to report to my manager used to be Peter Norvig at Google, and he would read the book first. So it's we're going to use Python. Okay, I'm going to just start reading the Python manual from page 1.
Yeah, my wife is like that.
Yeah. I mean, but I think that for me, what works is starting with some kind of problem. Mm-hmm. And what I've learned over time is actually even better than that. And this is where I'm not there yet, but I'm trying, is actually starting with a customer.
Yes.
I think starting with a person who has a problem. Mm-hmm. But before that, I think using yourself and saying, okay, what is a problem in the real world for me?
Yeah.
Starting with that and working backwards to, what AI thing do I need to build? And then what language do I need to build the AI thing?
Yeah.
And go from there.
Well, if I may tell the story of the most recent company, Helix ML.
Yeah, definitely dive into that.
So after DotScience, I did consulting for a few years and worked with clients all over the world, which was great. I really recommend it, actually. Being a one-man or one-person consulting company can be really amazing. But then what happened, I was watching this kind of open source AI space kind of towards the middle to end of last year, sort of August, September 2023. And I saw these two really interesting things happening. The first one was that Mistral 7B came out, And now suddenly, like, you could have like a good quality LLM, like a ChatGPT level-ish LLM that you could run locally on your own machine. And the other piece was that it became possible to both run but also fine-tune those models on consumer hardware. So you could now like have an almost ChatGPT level model that you could fine-tune on your own private data on like a single 3090, like the kind of gaming GPU that you might have in your home PC.
Now, like, let's dive into that a little bit for folks. So, a lot of people have heard the word fine-tuning, but like, how do people actually do that? I'll say what I think it is, and you can correct me and fill in the gaps. So when they trained Mistral, they had some PyTorch or TensorFlow or MXNet, whatever it is. They had some code to train Mistral. They give people that code, and so you can basically run that code on the current model and basically continue training on your own data. Is that pretty much how it works?
Exactly. So fine-tuning is just more training.
Okay.
So you take the weights of an existing model and you train it more on training data that is your own private training data. It is a little bit more complicated than that because there's a technique that's often used called low-rank adaptation, which I don't fully understand the math, but it's some sort of matrix decomposition where you end up just having to train like a much smaller set of weights than the whole set of weights. And that's really cool because it makes it tractable to train or to do more training on this model, but without needing like huge memory requirements. And that's what I mean by it became possible to like fine-tune Mistral yourself on like a single GPU. And that depends on that kind of lower.
So is it holding the original model in the CPU memory and then the GPU memory has the low rank version, or what's going on?
That's a really good question. I mean, I think everything fits in GPU memory, but I think it only needs to do backpropagation on the smaller matrix.
That makes sense.
Yeah, so it's able to like do that with fewer resources, and it also just takes less time.
Right, that makes sense. Yeah, because for folks who don't know, the way backpropagation works, and we talked about this a little bit in the AI episodes, but you keep this gradient matrix, so effectively doubles the amount of memory you need because for every matrix you need this sort of shadow, right?
Yeah.
And you might need to up the resolution too. Like maybe the model can run in 8-bit, but for training it has to be 16-bit, and so that now you're talking about a 4x multiplier. And so if you can just do inference on the big model, it can sit in 8-bit and then do the training on the smaller 32-bit or 16-bit model. That is really cool.
So I noticed these two really interesting things happening in the world, and I turned to my friend and co-founder Kai in Bristol, and I said, "It's time to have another go. Like, let's."
So was he with you at Dot Science? Okay.
Yeah, we kind of got the band back together.
Nice.
So for Helix, we saw this opportunity, and we went in, and we then like spent 3 months furiously hacking together the stack. I mean, we joked that it took us 10 years to know what to build in 10 days.
Yeah, that's how it goes.
But yeah, we put together this stack that allowed you to deploy these open source models like Mistral 7B and also fine tune them. And to make that easy for people with like a nice web interface where you just drag and drop in some PDFs or some documents. And then we did this interesting piece around the fine-tuning where we would take the source documents, chunk them down into little pieces, and then we would use an LLM to generate training data from those source documents. Because what you want to do when you're fine-tuning is train on data that's similar to the kind of questions that a user would ask of it, assuming it's an instruct style model, like a question answering model. So you can't just train it on like the raw text, because then it will just be good at completing the raw text.
Right.
But what you need to train it on things that are like the questions that users are going to ask. So we actually use another LLM to transform the source documents into questions and answers about the source document. And then we use those question answer pairs to fine tune the model. Our most popular blog post was how we got fine tuning Mistral 7B to not suck. And that goes into a bit more detail.
So maybe this is a dumb question, but these models are known to be trained on enormous data sets.
Yeah.
Right? I think there's one called the Pile. It's like 10 terabytes of text or something.
Yeah.
Some enormous amount. How does your fine tuning have any statistical significance when you compare it to just this enormous data set? Like how are you able to move the needle right on the model?
Yeah, so I think it has to do with like the learning rate that you choose when you're doing the fine tuning, and what has been found kind of empirically is that even just using a very small number of samples in fine tuning with like I guess a relatively high learning rate, so it makes the model change quite a lot, but not too much, because if you go too far, then it just goes like haywire and starts spouting garbage. So you've got to find this like middle ground. But even with a small number of samples, you can get the model to start generating things that are similar to like the fine-tuning data set, or start generating responses in a different style or with a different structure really quite quickly. And then it's about finding that trade-off. You don't want to overbake the thing so that it just kind of memorizes that and forgets all of its prior like learning from the pre-training.
Makes sense.
But yeah, we like tuned those parameters and we found something that worked. But then the interesting thing was, I guess, commercially, from a business perspective, is that we went into the market in December last year with two hypotheses. The first hypothesis was people will care about running models on their own infrastructure. People will care about local LLMs. And the second hypothesis was people will care about fine tuning, and in particular fine tuning for knowledge, which was that piece that we developed. And what we heard back from the market was a resounding yes to running models locally. So we launched on December 21. On December 24, this company shows up on our Discord and they're like, we're based in Germany. We're really interested in self-hosting these models. We're not ML experts, but we see the opportunity. And by January 1, they'd integrated Helix already into their stack.
Wow.
Like, this is incredible. This is like and then they were going after like big enterprise customers in partnership with us. And so that was like really exciting. It's like the universe was telling us like there is an appetite for running LLMs locally and building kind of the capabilities to make that easy to do. Now, in terms of the second hypothesis about fine tuning, we actually got a big meh from the market. Like, we put all this effort into fine tuning stuff. Everyone just said like, oh, we just want to do RAG, like retrieval augmented generation.
Yeah, interesting. Why do you think that is in hindsight?
I think because fine tuning for knowledge is slower than RAG, and the results are not as good. So like, it was kind of an experiment to see like, oh, well, maybe people will care about it. But yeah, I mean, and so what we did was we extended the stack. So we added RAG to it. And the other thing we did was we added API calling, which is where you can give the model an open API, which is confusing because it's not open AI, it's an open API spec.
Used to be called Swagger.
A Swagger spec.
Yeah.
It's easier to just describe it as a Swagger spec. So you give the model a Swagger spec, and then you give it a query from the user, and you basically say like a bit like how function calling works. You say to the model like, you've got these three APIs you can call, and please so it comes in three parts. The API calling. The first part is classify the user's question, and then tell you whether the user's query requires an API call, yes or no, and if so, which one. And then the second step is like constructing the API call. So assuming that you want to make an API call based on the user's question, like, can I rent a crane that can handle 3 tons in Hamburg next Thursday? Like, construct an API call that will query the product catalog with the correct question. And then the third part is taking the response from the API. So the system will execute the API call for you, and then taking the response from that API and summarizing it back to the user. Mm-hmm. So from the user's perspective, they're just saying like, hey, have you got a crane? And the model quickly says, yes, I've got one. I've got these 3 available. They cost this much. But what's actually happening underneath is that classification, API call construction, and summarization steps.
Interesting.
So that API calling feature has been really commercially successful for us, and tons of people are interested in that. And so I'll just shout out quickly to the fact that we did our 1.0 launch last week. So yeah, if you're interested in running models locally, we now run on Windows, Mac, and Linux. You can run it alongside Olama. We have a nice application editor, so you can like click buttons to set these things up and add knowledge with RAG, add API integrations, and so on.
So if people don't have, let's say, a GPU, could they still run Helix on, let's say, an EC2 instance?
Yes, and you can even just run it on CPU because Olama runs on CPU as well.
Okay. Got it.
However, if you have a Mac, like one of the more recent M1, M2, M3 Macs, Olama also works with the GPUs on those machines. So you actually get really quite good performance on a Mac. On a CPU, Linux, or Windows machine, it will be a bit slower. But if you've got like a gaming rig at home running Windows, then you can install WSL2, like Windows Subsystem for Linux, and Docker, and then the whole thing does work.
Yeah,
which is pretty cool.
That is awesome.
So yeah,
or you can dual boot and have a Linux machine with ZFS on it.
Yes,
that is another option. That's really cool. So how does that work? It's like a desktop or a library. I guess I'm trying to figure out. So in the case of OpenAI, they give you a key, and you're calling into their server with their key, and that's how they do billing and all of that. Mm-hmm. In your case, how does that work? Is it, I guess, also a key, but you get the key from helix.ml?
So we are Docker desktop license. Mm-hmm. So like if you have less than $10 million of annual revenue, then you can use us for free.
Perfect.
Just download it on the website, it's an install script. So you just like run our installer. That creates a Docker Compose file. You run Docker Compose up, and then you look at like localhost in the browser, and like the whole thing is running there.
I see.
But that means, of course, you can then also deploy that. If you're a company, you can deploy that on your own internal infrastructure, and that's where kind of the DevOps piece comes in. We also support Kubernetes, so you can run the whole stack on Kubernetes. We like use Kubernetes with a bunch of GPUs in production for our own service.
Very cool. This is fascinating. Okay, so maybe we'll wrap up with like, what's one last piece of advice for, let's say someone's listening right now and they are completely infatuated with this. They want to get into MLOps. We talked a little bit about, kind of things to study and all of that, but in terms of maybe more of a sort of like a mindset or kind of lessons you've learned, on the soft skills side, what are some advice that you can give to folks out there who want to get into this field?
Yeah, I mean, I would recommend like joining the MLOps community. So you've got like, or other communities to have peers to talk to about it. And then, I would say start playing with the technology. Yeah. Like I said earlier, if you want to get into MLOps, like play with Python, Git, Docker, PyTorch, that kind of thing. If you want to get into this newer field of LLM ops, like how you manage RAG and API integrations, kind of on the other side of the LLM API boundary, if that makes sense. Mm-hmm. Then download Olama and spin up an LLM locally. And if you like play with Helix and set up like an API integration, and then that'll set you up well to be able to go into maybe like a job interview or something and say like, I've got this experience, or to build a side project.
Yeah, totally. Amazing advice. I think we actually covered Docker in the Kubernetes episode, which is we should have, in hindsight, maybe had a dedicated Docker episode. Mm-hmm. But check out the Kubernetes episode if you haven't already. We talk about Minikube, and there's probably better things out there. That episode is a little dated now.
That's okay. Minikube's solid.
Is it still the thing? Or
there's Kind as well.
That's right. Actually, I used Kind recently. Yeah. Get set up on your machine and check out Helix ML. Totally free for folks out there. If you're going to install it on your work computer and you work for like Google or some company that has a lot of revenue, you probably need to check with your boss first.
Or just come talk to us on Discord.
Or just talk. Yeah, exactly. If you're a hobbyist, just install it and get started and try things out.
Yeah, awesome.
Cool. All right. Thank you, Luke. Thank you so much for your time. It's been awesome.
Thanks for having me on.
Cool. All right. So as part of this 3-parter, we just had Luke on to talk about what is ML ops and kind of get us started on that and explain his story. And now I'm really excited. We have Yuval Fernbach here, who's the CTO of JFrog ML, and he's going to explain to us more about the whole kind of supply chain of AI software. So thanks so much for coming on the show, Yuval.
Thank you, and really nice to be here.
Cool.
Yeah, it's a pleasure to be here.
Yeah, and just a recap, we are at the SwampUp conference, which is, I think, hosted by JFrog.
Yeah,
right?
it's hosted by JFrog, and it's actually my first SwampUp, so
cool.
I'm really excited to be here.
That is awesome. So before we dive into ML ops, why don't you tell us a little bit about your story? What kind of led you to JFrog?
Sure. So previously, before joining JFrog, actually only 2 months ago, I was part of Qwak. Qwak is an MLOps platform, and I was one of the co-founders and CTO for Qwak that was acquired by JFrog end of June, and now basically part of JFrog ML. So before being part of Qwak and founding Qwak, I was working for Amazon Web Services for 5 years. I was part of the AWS machine learning service team, basically working with the AWS customers on their challenges around machine learning. So I've seen hundreds of customers, hundreds of companies trying to solve that, trying to understand how they can start iterating on machine learning, building models, experimenting, and eventually impacting the business based on machine learning models and AI applications. And that's basically one of the main reasons why, together with my other co-founders, we decided to found Qwak and help those companies to actually achieve that, to make sure that they impact their business and build models, not just for the research or for the development, but actually making that supply chain work and affecting their production as well.
Cool. So, I think one really unique story I'd love to dive into is you were at AWS, which is a very large organization, right? Roughly how many people are at how many engineers at AWS? Maybe tens of thousands?
I've been there for 5 years, and in that time it changed from, a few thousands to probably tens of thousands by the time I actually founded Qwak. So it changed quite a lot. I'm not sure what are the numbers right now, but by the way, it was amazing to see how a company that was relatively small, at least versus Amazon, actually grew and became such an amazing business.
Yeah, definitely. Yeah, I feel like the documentation, the quality of service of AWS, I haven't used other ones recently, but I remember this is years and years ago, looking at all the different options and just seeing just a higher level of quality for AWS. Like things just tended to work, and the documentation was really well done. And that there's an extraordinary amount of effort and user study and things that go into that.
Yeah. I must say that I learned a lot during that time, because I've seen, the company that basically founded the cloud, or the first company that created the cloud, that understood that their customers are not IT, their customers are developers,
right,
that need to build software. And they build that as a self-service, basically, product-led development before anyone talked about it.
Mm-hmm.
And I think that one of the reasons why eventually we founded Qwak is that we saw how that company grew. There were so many services, and it became really, really difficult for companies to actually utilize the different services, and not just utilize different services, but the challenges have grown. You cannot just use EC2 and S3 anymore. You need like different higher level solutions to make your product work.
Mm-hmm.
And I believe that it's amazing what AWS built. But nowadays, I think that in many cases, using those building blocks directly and trying to build on top of that is actually too much for many of the companies. And actually, the amount of investment that they need to do to actually do that, the amount of engineering work that you need to do to build, for example, an ML solution, is just too much for many of the companies. And it's really difficult to do that.
Yeah, that makes sense. I kind of experienced this firsthand, where you can stand up things with the web UI, and so it's like, I want an EC2 instance, I want a database. But then at some point you need to programmatically do that.
Yeah.
It's like, oh, I need a beta database, and the beta database needs to have all the same things. And you just forget what you clicked on a month ago. So you need this infrastructure as code, and then that's a rabbit hole, and it's hard to hire people who have that talent, and so it becomes difficult.
Yeah. It's actually amazing to see how companies have grown to a place where they understand that it's not single point solutions. You need to create platforms. So, for example, going to the software supply chain, understanding how a software supply chain looks like. It's not just a CI/CD. It's your source code and how you manage your binaries, and then how the security infrastructure looks like on top, and then why software engineering is different than data science, and how it's all connected to the same supply chain. And eventually, this challenge is not just spin up instances and databases and writing code in Git. It's way more than that. It's having a system that can actually work in scale and allow your company to be efficient, both in once you have like 2, 3, 5, 10 developers, but the same efficiency once you have thousands of developers, and you want to actually make sure that you deliver on time, and not just deliver on time, but you delivered a trustworthy product that you can trust, both in terms of the features, but also in terms of the security, and make sure that they work in production exactly the way that they should, based on your product spec, for example.
Yeah, that makes sense. So you went from, giant company to Qwak. Right? I'm assuming, maybe a handful of people when it started.
Yeah,
10
sure.
people or so. Yeah, and so
when it started, it was 4 people, but of course we grew over time.
Yeah. So was there sort of a shock, the moment you went to Qwak and you're like, wait, there's no IT department. There's just me, like how did you navigate that? Because I know a lot of people who go from big to small company, and there is a risk. Like there's some people where it just doesn't work out. And I mean, that's okay. They go back to Facebook or whatever, but what was that experience like for you?
There's always a risk. And I think that founding a company, being one of the co-founders, even one of the first employees, is not for everyone. And that's great, because I think that the challenges that you have doing that are different challenges, different experiences than working with, a giant company like Amazon.
Mm-hmm.
So I personally love it. I think it's an amazing experience. I love the fact that it was on me. Like if I had a problem with my computer, I needed to fix it. I needed to talk with, the person that we bought the computer from. It's part of like the experience of founding a company, being part of a small organization, a startup. So I really love it, but of course it's not for everyone. And I think that one of the challenges is that you need to make sure that you focus on the right things, the right challenges, because there are many things to do, but your main goal is always to build a successful company and make sure that your customers actually, get the benefits of your product. The customers are actually happy with the solution that they get and want to use you, and of course recommend you to their friends and colleagues.
Yeah, that makes sense. So maybe before we jump into the MLOps stuff, what was Qwak? Like what did Qwak do, and what does Qwak continue to do through the acquisition?
So as I said, Qwak was founded 4 years ago, and we started from day one to focus on this challenge called MLOps. So basically allowing companies to start from the development to the production without the need to manage multiple solutions, multiple platforms, and even like utilizing or actually handshaking the code between different stakeholders during that process. So from day one, our main focus was production, how to make sure that models will work in production, and of course going left or going back from production on how you can make sure that this supply chain actually work from the development to the production and smoothly as possible. So we started with that, and I think that one of the challenges with MLOps is that it's not just around the models, it's around the data as well. Mm-hmm. So you need to both have that solution for data that allow you to, again, have data for production, have data for inference, but also data for training, and have the way to manage that data, those features. The same way as you do that for models, and of course nowadays the same way that you do it for Gen AI applications, LLMs, things that are a bit different by nature, but eventually are based on the same like infrastructure and the same needs in terms of their basic needs.
Yeah, that makes sense. I think a unique challenge about AI is the problem of leaking the label. So, for example, let's say you fine-tune a model on a series of questions and answers, and then you use those same questions and answers to evaluate the model. Well, it's going to be pretty good. So that might sound like obvious, but it's actually really difficult to not accidentally leak the label. It's so difficult to keep sacrosanct like your evaluation set and keep it from accidentally, especially when you're doing aggregations at so many levels, from accidentally sort of poisoning the well.
I fully agree, and I think that like having the proper data platform for AI and machine learning applications is actually crucial, because it's not just making sure that you manage the data set right and understand what's the difference between a training data set and evaluation data set. And I agree that's crucial because that's the only way for you to understand the metric of a model. It's also understanding that the data that you build the model on is actually available during prediction, during inference. So, and by the way, this is, I think, one of the reasons that many ML projects fail is because data scientists are doing research on the data. They get the data from, the data warehouse. They train the model, but eventually that data doesn't exist during prediction. It doesn't exist during inference. And many projects fail because they created an amazing model, but they don't have this data when the application needs it, when the application calls the model. The application doesn't know, the history about that specific persona during that time and cannot get that because maybe it wasn't calculated yet. And one of the things that we started with in Qwak is to create a feature platform that allowed you to create both an offline feature store and an online feature store that are basically based on the same calculation. The online feature store allows you to get a low latency current value of your features, while the offline feature store allows you to get all that training data that was calculated exactly the same. So you know that there is no basically drift between your offline or training data and your inference data. It's exactly the same. It was calculated the same, and the data that you were trained on is actually available during inference.
Yeah, I mean, that, the story I always tell folks was there was this product called Google Plus. It died along with a whole bunch of other Google products, but we were doing the friends suggest and a bunch of ML stuff for Google Plus a long time ago. And there was an issue where the day of week feature was 0 based at training and 1 based at serving. And so Sunday didn't exist. And Saturday, I guess, also didn't exist. Or I don't remember exactly what happened with Saturday. I think it was a one-hot encoding. Yeah, so Sunday and Saturday both didn't exist. And it caused all kinds of chaos. And it was extremely difficult to find because you just would give bad suggestions on the weekend. And there's no compiler error. There's no easy way to find. They were written in 2 different languages, the training and the serving system. So yeah, I think there was a product Feast, which was a very early attempt at this. But how has that evolved? Is it to the point now where you can write it once and it works on both?
So I believe that the feature store is a crucial part of an ML platform, and Feast, by the way, is an open source that still exists. Mm-hmm. But I think that one of the main challenges with such solutions like Feast, like the cloud vendor solutions for feature store, is that it's not just about the storage. It's about the data pipeline as well. You need to have a data pipeline that eventually can connect both the offline and the online on a single process. So you write your code once in the same language, and that code will be used to create the data for both. And again, it's really connected to what you just said, because in the past, many models were, for example, written in Python, but then the production implementation was, let's say, in C or Java or whatever. And you needed to recreate the features in a different language. And there's no actual way to compare the two and understand that the features were created the same. So many companies had the same challenge that you just talked about of having that the difference between the production and the training. And again, it's the same challenge with a feature store that are only the storage level like FIS and like others, because you need to have that same data processing layer that will be used to create like both features. And I must say that part of it is that Python now actually grew enough to be good enough for production, because it's not like, in many cases, it's not really Python production. You build a model in Python, but then eventually it's a C object that's running in production, although the code is still Python. So you can actually use the same code and get pretty good performance. So that's, of course, part of the technology enhancement that happened during those years.
Oh, very cool. So, a lot of projects start with Jupyter Notebook, which is kind of itself kind of this extension or descendant of Mathematica, right? Mathematica Notebook, which is this beautiful, like, interactive thing. And it just becomes really hard then to productionize that, because it's not .py files, it's all these cells. And so how do you recommend for folks to go from that notebook to something that can run at scale?
So it's a great question, because I'm here to talk about supply chain, and that question eventually pivot me back to supply chain. And I love notebooks. I think that notebooks are great for some things. For example, if I want to visualize data, if I want to have an interactive environment, notebooks are amazing for that. By the way, IDEs are amazing for other things. For example, debugging code, IDEs are way better for that than notebooks. There are advantages for each one of them, but both are not built for production. Like, eventually, when you want to build for production, you need to have a proper CI. You need to have a proper supply chain that move that code to be an artifact, and from being an artifact, eventually deploy that. And of course, making sure that you have a lineage between the deployment, the artifact, the source code, all that should be connected in a way. So what I've seen is that notebooks are great, are amazing, but eventually once companies understand or graduate to the place that they want to be to production, they need to add more structure to the way they build the models. And for example, one of the things that we've done in Qwak and now with JFrog ML is to have an opinionated way of how to build models in terms of structure that allow every new data scientist to look at the model that they never looked on before and understand, okay, this is the training of the model. This is the code for the inference. This is the code that fetch the data from the feature store. Like, immediately understand the structure of a model, immediately understand how that model was built, and be able to help or train a model that they haven't seen before just by looking at the code and looking at that structure. So I believe that notebook have its part of the research, but in some phase you need to move from the notebook to have that code manage, for example, in a source version solution. So let's say a Git solution, in a way that can actually be automated. So you need to have some kind of a structure of what's the training job looks like, what the prediction looks like, what's the dependency, what are the dependencies, which packages you need to run that model, because packages, especially in Python, a new version come out and break everything. So you need to actually, freeze those dependencies to make sure that you have that model actually reproducible and not just trained once on a notebook on someone's computer and will never work again.
Yeah, definitely. Yeah. And you have to be able to go back as well. Like, we did these really hacky things, but there's got to be a principled way. Like, once you have it in source control and it's in production, you're always going to want to do more data science, because you are going to change the product. The product changes without you because new customers adopt and some churn and everything. And so, being able to run a Jupyter notebook on your production code and then make changes, that whole integration is extremely complicated. But so valuable.
Models degrade over time. That's I think the way model looks like, because data changes over time. So part of having the structure. So by the way, one of the things, for example, that we do with JFrog ML now is that whenever I build a model, I automatically basically copy or freeze the source code that I used to build that model. I freeze the dependencies that were used to build that model. I create the model artifact, the trained model, but I can reproduce that model at any point in time.
Mhm.
I know which configuration I used. I know what was the source code I used. I know what is the data set that I've used. And I think this is a practice that companies must utilize. Practice must make sure that they have the ability to reproduce a model, because they will need to train that model again. They will need to fine tune it. They will need to understand if even without model monitoring, and even without really looking at the data and seeing the drift, it probably happens.
Mhm.
And if it happens, it means that they will need to retrain that, and they will need to have the structure that allow them to retrain that, even if the data scientist that built that is not available anymore, is not in the company, or just your team grew and you have more projects.
Yeah, that makes sense. So on episode 158, we actually had Bill Manning from JFrog come on the show and talk about software supply chains. And so folks should definitely listen to that episode if you haven't already. So what's the delta between that and AI supply chains? How does AI kind of make that problem different?
So first of all, the process itself looks different. Like, an ML project starts from research, it starts from experiments. You need to track those experiments. Those are phases that do not exist with software. Usually when you build software, it happens because of two reasons. First, you have a new feature, and second, you have a bug. So those are the reasons why you start working on a software project. But with ML, it's also because your data have changed. It's also because you have more features and you want to make that model better. So there are many reasons why to work on an ML project, and it always starts with some kind of research experiment, and those phases looks entirely different in terms of AIOps, MLOps. Same for the deployed model, because the monitoring that you do for software is only the infrastructure monitoring, maybe logs analysis, maybe understanding if there are bugs and what are the latencies of different processes and those kind of things. But with models, you actually need to monitor the data as well. You need to monitor the model and make sure that this model actually gives the right impact on the business. Make sure that this model doesn't degrade over time. So the process itself looks a bit differently, but eventually what happens in the software supply chain process is that you have code, then you create artifacts, and then you deploy those artifacts. And those parts are the same with AI, with ML. Maybe some configurations are different. Maybe, for example, nowadays with AI, you have also prompts as part of your artifact. Maybe you have an external model like, I don't know, ChatGPT or something like that. And there's a new version, and it's not something that you manage, but it's still an API that you call. It's still an application that you need to manage. So eventually it's the same artifacts behind the same idea, but different processes. And even the security posture, even the understanding if a model is trusted or not, is trustworthy, that's pretty much the same as any other kind of software. So if you build software and you scan those software and you scan the dependencies and you scan your runtime environment, and you don't want to make sure that the same software that you build in runtime don't have vulnerabilities, and you scan it from the source code and up to the runtime and understand how your security posture looks like, it should look the same with machine learning, because eventually those are packages, those are artifacts and third-party APIs that need to be secured and need to make sure that you manage that lifecycle in a way that you trust.
Yeah, that makes sense. This was awesome. Thank you so much for your time. This was really great. One last thing you have for students who want to get into this field. What's some advice you could give them?
So first of all, it's an amazing field, so do it.
It's great advice.
But second is that I think nowadays with all the Gen AI models and LLMs, the entrance point is actually easier than in the past. Mm-hmm. Like in the past, you needed to understand the statistics around the data, and you need to add these data to start training models. And there was quite a lot of understanding, quite a lot of work you needed to do to actually have a model ready. And nowadays, you can start in understanding that, just by using, for example, ChatGPT.
Yeah,
I think that as an example, my father only now understand what I do because they understand ChatGPT. He saw how model looks like and what are the effect of models. So I believe that this is a great starting point for every student that want to start learning about machine learning, about AI. Play with those tools, understand how a specific prompt change the way the model reacts, And eventually, those are models that are maybe more complicated than the models that we've done 5 years ago or that we use for specific point solutions. But eventually, those are models that uses the same technologies behind the scenes, and understanding how those models behave will give you quite a lot of knowledge about how model development looks like and how you can utilize machine learning for every kind of task.
Very cool. Thank you so much, Yuval. I really appreciate your time.
Thank you very much.
All right, everyone. So we have been talking in this episode about ML ops. And I'm really lucky that we have Stephen Shin on the phone, who's done a lot of really interesting work with this. And we're going to focus on LLMs and GraphRag as kind of two case studies of getting ML and AI implemented, and then what that whole process is like, and then getting all of that into the hands of customers. So welcome, Stephen. Thanks for coming on the show.
No, very glad to be here and excited that I'm speaking at SwampUp actually on the same topic. So I'm going to be talking a bit about knowledge graphs plus LLMs, and in particular, how you can apply them to your DevOps pipeline.
Cool. So before we jump into all of that, why don't you give us a quick background? What was your path that kind of led you to where you are now, and what are you doing right now?
Yeah, so maybe we'll start with where I am and go backwards. So I'm VP of Developer Relations at Neo4j. Neo4j is a graph database company, but also does a lot with generative AI and machine learning, and is building out architectures for GraphRag that a lot of enterprises are using. Before this, I was working at JFrog for basically the same role, VP of Developer Relations. And I did this at Oracle, slightly different role, but basically the same role. I was running the developer marketing team. And the way I kind of got into developer relations in general, because I was also a developer advocate for a bunch of years, is I made the mistake
Okay.
of writing a book.
Oh, okay.
Now, I'm not discouraging anybody from writing books. It's a wonderful way to increase your reputation, to teach and explain things which you're passionate about to a larger audience. And when I wrote the book, I was fortunate enough to have some great co-authors who I collaborated with on the title. It's a lot of work. You're basically giving away 6 months to a year of your life, where you have no weekends, no evenings, especially if you have a day job that you also have to keep going. And then when you finally finish the book, the publisher says, that's a wonderful book. We've released it on, Amazon, bookstores, etc. But can you help us promote it?
Oh,
you become the promotion arm for the book. If you're not submitting to conferences and talking on the topic, if you're not on social media, if you're not out there, being a vocal advocate for the technologies you care about, and obviously pointing out that there might be a good book that folks can read for more information, then you're not doing your job. Now that first book I wrote, oh my God, it must have been, I'm dating myself, 15 years ago.
So you knew a technology, and a publisher approached you and said, Stephen, you are really gifted in this technology. Why don't you write a book on it? That's kind of how that went down.
Yeah, and actually, when I was in college, I assumed it was the opposite. I assumed you wrote a book, and you went to publishers and you said, "Look at this great book that I wrote. Would you wanna put this under your brand and publish it?" But no. Publishers, especially tech publishers, work exactly the opposite. They have a roadmap. These are the titles we want to publish. These are the topics that matter to us. Occasionally, you can influence that, but not until you're an established author. You have really good relationships with the editorial group. Mm-hmm. And they then say, okay, for these books we want to author, for these titles we want to author, who would be a good candidate? Who has the expertise, who can authoritatively write a book and help us market it later on.
And so you had the footprint then that they were able to find you. So you had done some kind of promotion to get to that point.
Yeah. So, it was for JavaFX technology, and I got in really early, beta days. Was already
okay.
building applications with it, had a lot of good connections in the JavaFX community. And I got invited with somebody else who'd written another book with the same publisher. And now this was the first real JavaFX book. Now, fast forward 15 years later, and we got asked to update basically the same title for Java 21 and 23 with all the latest features and capabilities. So it's become, for this small niche market, JavaFX, which I don't actually do professionally anymore, but I still keep up on it, and I act very close with the community. This has basically become the authoritative guide for client developers in Java.
Wow. I'm totally dating myself here, but the last time I professionally wrote Java, it was this thing called Google Web Toolkit.
Oh, yeah.
And you would create JavaScript with Java. This was one of these, like, in hindsight, in my opinion, really bad ideas. I mean, maybe not. But and I was writing, I think, in Java 6 or something, and it was compiled to JavaScript and all. It's kind of it's a really strange. I mean, that was my first introduction to Java.
Yeah,
it's a very strange way to get started.
GWT was kind of an interesting approach.
Yeah.
I think we've come a long way there with JavaScript frameworks, which do all the heavy lifting. So basically, you can have a very feature-rich application without a heavyweight backend.
Yeah.
So I think that's become the modern development framework. GWT was an attempt to do that, have the heavy front ends, but then have you write it entirely in Java and then deploy all that JavaScript magically and like have the web application like just appear. It's technically difficult to do that perfectly, and therefore it couldn't keep up with like modern JavaScript frameworks.
Yeah, I mean, and then on the other end, it really got squeezed by Node, because the advantage of GWT was, for example, you could write validators in Java and validate the client side and the server side. But now you can do that with JavaScript. Yeah,
and again, for reference, the Google team accepted and endorsed the use of both GWT and GWT for the same acronym. So they would use both.
Yeah.
They never agreed upon what it was supposed to be.
Makes sense. Cool. So, okay, fast forwarding all the way to current time. So you are actually, before we dive into LLMs, let's talk about this a little bit. So, what is a developer relations advocate, and someone who leads a team of advocates? What is that job? Because we're going to dive into a lot of technical content here. And when people think of public relations, they think of speeches and writing speeches for candidates and these kind of things. But developer relations, you're actually building a lot. So why don't you kind of give people a little bit of scaffold there?
Yeah. Okay. So for those folks who don't know the job or role of a developer advocate, basically a developer advocate is somebody who they're advocating for developers, both in the product. So if you work for a company, like saying, hey, we have these users and they're trying to do things with their product, like let's actually help them out and build features which are going to be beneficial to them. But then also educating developers about new ways of doing things, new techniques, and kind of upskilling, helping them upskill. And the way I would describe a developer advocate, like the most simple description is a developer advocate is a geek with social skills.
All right.
So you have to be technical. You have to be able to write code, be like up with the latest technologies and trends, and constantly learning, like picking up new technologies. But you need to be like able to present, able to do interviews like this, to kind of be very fluent. So strong English skills, like strong presentation skills, those are all really important. And you can actually come up to be a developer advocate from either a highly technical role, like a lot of developer advocates start their career as programmers and architects, and like they get tired of just building things, like they want to kind of move up and actually be the change agent for industry and for folks who are adopting technologies. So it's a great career path past, like, what do you do when you're tired of just being the most technical person at your company? On the other hand, you can also become a developer advocate by having great social skills and great kind of English language presentation skills. And one of the folks who I just hired, their name is Nia Macklin. Also a speaker at SwampUp.
Cool.
Got accepted before even joining my company. And they came up through a background of journalism and politics, kind of being involved in political campaigns, being involved in kind of all of that writing, outreach, campaigning, and wanted to move to a more technical role, wanted to move to something which was more technical. So they went back to a boot camp, kind of learned Python, JavaScript, all the basic skills, all the way up to, building web applications, like deploying technologies. They were a developer advocate at Couchbase, now a developer advocate at Neo4j, and very early in their career. Like I would say that this isn't, to be a developer advocate's not something that you have to be old and gray to be a good developer advocate. Some of the best developer advocates, actually most of the best developer advocates, mirror the audience. So if you're talking to a technical audience, you want to be like able to just talk to them as peers. If you're going to a university and speaking to them, you want to be able to talk as a recent graduate. Kind of like being very close to the audience, I think, makes it more credible and makes you more effective in the role.
Yeah, that makes sense. Very cool. Yeah, so folks out there, this is one of many really interesting professions that we're going to learn about here in these sessions. So if you have any questions about this or any other professions, don't hesitate. Shoot emails to us, post in the Discord. Feel free to kind of keep that conversation going. There's a lot of really interesting activity on Discord, and feel free to join and be a part of that. Okay, so let's dive into LLMs. So LLM stands for large language model. I think now they're starting to call them foundation models because you have vision and all these other modalities. But what is a large language model? How would you describe that to somebody?
Yes, I think that this in the past has kind of required a technical explanation of like, how you train the models and then how you can actually build the models to learn by feeding them extremely large data sets and then having them kind of iteratively complete the next word vector or kind of the next idea in a chain of commands. Now, actually, it's much easier to explain this now because everyone's using it.
That's true. Yeah.
So if you're using ChatGPT, if you're using Copilot, if you're using like any of these tools, which kind of give you a language interface to talk to and interact with your code, with like the web, with an enterprise data set, then you are using an LLM behind the scenes. And, you can see that it's a very effective tool for a lot of tasks, which are, for humans, are time intensive and require a lot of knowledge entry, which require a lot of knowledge gaining. So it's great for summarizing information, great for writing emails. Excellent. Don't recommend this at home for writing research papers. Not right. Research, but like class papers, like things which the professors say, "Oh, research this subject," and then write a 2 or 3 page paper. Like it's
that's
amazing at that. But of course, completely against most schools' rules on.
That's right. Don't violate your school policy. It's really good at portmanteaus. You can say, "Give me." A portmanteau of these two concepts, and it will come up with some incredibly brilliant, names of companies. It's really good at that.
Now, I would say what LLMs are poor or they don't have a strong ability for is, in general, they don't reason. Correct. Like we do.
Yeah.
So if the source material, if the context is rich enough to kind of piece together and give clues on what the answer is, it can both kind of pull from that body of knowledge, but then it can also synthesize information which maybe is not clear from the very large. Like they feed these systems with hundreds of billions of words and like huge unstructured document sets. And so it does kind of these amazing leaps, which seem like reasoning, but they're not actually reasoning as humans think and reason. And also, a related thing which they're poor at is math.
Right.
So in general, like it's not they work as simple calculators and can answer basic math questions because, again, like that's all exists in the source material. Or they can specifically train the models and add in things for common questions which get asked. So they do a good job of calculating and returning a result via going to an agent or some other system which is specialized. But in general, they're not designed for math. And if you give them a complex problem, like I was playing around with one of these kind of online LLM games where you're supposed to trick and hack the LM.
Oh, that's a thing.
And it was kind of fun. Like they set it up as the LM thought it was like a wizard, and like it was protecting like some secrets, and you were supposed to like convince it to give you the secrets. And basically, they had multiple levels for difficulty where they add additional prompts, which would prevent you from doing attacks, which will allow you to circumvent the LM. But basically, the way to hack it is you did a combination of reasoning and hard math problems. So you'd ask it to, for example, do like a Roth 13 algorithm or something complex, moderately complex, and basically you ask it to give you an answer, apply a math algorithm to it, and then the system which is checking the answer to make sure it's not revealing secrets now can't check the answer properly because you've encrypted it.
I see.
But what you learn when you keep giving it harder and harder and harder math challenges is it actually falls apart. Like it, for example, like rotation ciphers, it'll consistently get the first few letters right. It gets worse and worse and worse as it goes along because it gets lazy and it doesn't really care about.
And then
answer.
I noticed if you tell it it's wrong, it'll get better. It's almost kind of like reinforcing an animal or something. It's like, oh, I'm so sorry. Here you go, and it'll get a little bit better, but never 100%.
Yeah, and then the ultimate answer was to actually give it like small snippets of code to generate or compile, because again, the web is full of so much code, and those systems are also tuned for doing a certain amount of code challenges and problems. Mm-hmm. So the hardest reasoning problem you can give an LLM actually is to do coding. So you combine that with like asking for some information or like trying to hide some information. You can actually trick it to do quite amazing things.
Oh, interesting. So, okay. So, I think that, when people think of LLMs, a lot of people have used ChatGPT, Perplexity, these other things. And that's a pretty straightforward, from like a product standpoint, use case where you go to chatgpt.com and you're literally just a blank screen with a text box. You type what you want. And so it's the simplest product you can make. And it's because their technology is really impressive and they just want to focus on that. What are some other places, maybe less obvious, where LLMs are being used in the real world?
Yeah, so I was mentioning things which LLMs aren't good at. And an additional one which LLMs are not good at is, since they're trained on mostly public data, they really know nothing about enterprise systems. They know nothing
you could
about.
Ask it about your email, things in your email, for example.
Yeah, and like similarly, if you're in a company which does, supply chain management of like parts and things for aircraft, you can't ask it about like what's the part number or what's the what parts do you need for a certain maintenance operation on a plane, because that's just not something that's generally available to LLMs to be trained on. So one of the techniques you can do with LLMs is you can do something called retrieval augmented generation, where you feed in a body of this additional knowledge, additional information could be from a database, from a bunch of documents, from some other source which is not public. You embed it in a vector database, and then when you query the LLM, you first query the vector database, the vector store. You ask it for information which relates to this. You pass that on to the LLM as context. And now the LLM, which is very, very good at answering abstract questions, now becomes an expert in this new data set and this new knowledge set. But with kind of the same limitations, where it's not good at reasoning, it's not good at a whole bunch of things. And this produces another problem, which is so getting back to the aircraft example. Let's say I'm a technician. I need to perform maintenance on the fuselage of an aircraft, and I want to know, like, for this particular aircraft model, what what part number do I need to do this repair, which I'm trying to execute? Now, if it's not exactly in the source material, if like maybe the relationship between like the maintenance operations and the parts isn't clearly spelled out, the LLM won't say, "Oh, I don't have that information. Like you should maybe talk to somebody who's done this before." What it's going to say is it's going to say, "Oh, well, if you're doing this sort of operation, there's a number of different things which you could use for this, and I'll give you a list of different parts which are totally plausible, and I'll tell you any of these would work, and just go ahead and."
Oh man.
And
I think you're explaining a lot about like Boeing doors falling off airplanes.
I hope they're not using LLMs for their maintenance on Boeing planes. But you can see that it's for enterprise use. You can actually get pretty far with an LLM, but it has problems with what we're currently referring to as hallucinations. Where basically the model will extrapolate information which may or may not be true. And depending upon how good the source information is, how good the encoding is, you can get to some customer support systems, they get to maybe 60-70% accuracy or accepted answers when a customer support representative looks at this and says, is this the right answer to give a customer? But the question is, when you get to that accuracy, let's say you get to 80% or 90% accuracy, is that good enough for aircraft maintenance, for supply chain management, for fraud detection? Like there's a whole bunch of critical use cases. And like is that good enough? Is that accuracy good enough? And then the second question is, when it's wrong, how do I know it's wrong? How do I check the system? How do I explain how it got the results? So this is actually the subject of my talk, which is there's another way which you can encode enterprise information, which has been in use for a while. It's called knowledge graphs, or property graphs, basically the same thing. And a lot of expert use systems will use knowledge graphs as the system of truth for capturing data, kind of building expert systems. But the typical problem with those is to build an expert system on top of a knowledge graph, you need an interface. So you need to build like an application, like you have to have a bunch of like queries and drop-down menus and things for people to find information. So wouldn't it be nice if you could ask the LM, but then have it give you information from a knowledge graph instead of just randomly pulling information out of a vector store? And so this technique for pairing knowledge graphs and LMs together is called GraphRag. It's a really effective way of improving the accuracy of your results. There was a study recently done, I believe, by Gartner, where they showed a 54% increase in accuracy just by switching to knowledge graphs versus like traditional vector stores.
Oh, okay.
It makes it easier to explain the results because part of the knowledge graph gets passed into the LM as context. And knowledge graphs, unlike vector databases, actually you can reason about them. You can see what are the nodes, what are the relationships. You can actually start to understand why the LM was giving a correct or incorrect answer, and then go back to the source data and fix it.
So is the LM translating your English request into a knowledge graph query? Is that how it's working? Or is it just more fundamentally integrated with the knowledge graph?
Yeah, so it's doing a couple things. So when you take the source material and you put it inside of a graph database that also supports vector search, it's doing a standard vector encoding using word vectors of the embeddings. It's also using an LLM to create a graph, and you can hand make a knowledge graph. You can also tweak the resulting knowledge graph, but a really quick way of doing this is to actually use an LLM to generate the knowledge graph off the source material as well. And once you have a knowledge graph plus the vector database and linkages between them, now you can basically feed it into the vector store, the question, get back some embeddings, see what nodes they're associated with, and pull the related nodes, and then feed that all as context into the LLM. And so basically it's a better vector search because it's vector search which includes knowledge graph and real data coming from the LLM.
Yeah, that is super cool. Okay, so to have folks deployed GraphRag, different industries, and tell us maybe like kind of good story, bad story kind of thing. What's something maybe hilarious that came out of it? And what's also something where kind of at scale you had kind of an aha moment or a eureka moment?
Yeah, so I think a lot of our customers are using GraphRag and graph databases for specifically to solve the problem of getting higher accuracy on RAG. Some of our customers are using it for, in particular, customer service systems. That's one of the common scenarios. A second one in general is recommendation engines.
Oh, that makes sense.
So trying to give back like better search results, like better recommendations to end users. And actually, we had an interesting use case where this is a different use of LLMs. It still generally falls under GraphRag, but it's more of a research system than it is a query system. Where one of our customers maintains oil fields and kind of that oil infrastructure, and making sure that the supply chain is uninterrupted is important for them. But there's so many data points in terms of conditions and maintenance issues and weather conditions that it becomes very hard to even understand root cause analysis on why things are getting delayed or slowed down. So what they did is they fed huge amounts of data into an LLM using a graph representation of this, using a graph store, and then had the LLM start to reason and give some potential answers about where the issues were with outages or supply chain issues or things in there, and got some interesting insights. Now it's a humongous model, very slow to load up the massive quantities of data and things which they did. But from a research standpoint, they got some really valuable insights, which would have required like a humongous amount of human manpower and research to actually go through the data and build those insights. So I think there's a variety of different use cases for it. Now I'd say the biggest challenge, and like those are all successful production ready systems I talked about, but the biggest challenge in the kind of the white elephant in the room related to LMs and in general Gen AI architectures is it's all startups and very little's in production. So like when you actually get down to it and you're like, okay, well, how many people are using, LangChain or Llama or like these models in production? And they're like, oh, well, we have a really promising system, and like we're getting the accuracy up, and like we're almost there. But I think a lot of folks are almost there and are kind of looking for the technology to mature.
Yeah.
And also for like the cost to be reasonable as well. I think that it doesn't doing research and doing development in LLMs, it makes sense because the technology is not that expensive to prototype with. When we were doing at scale, large volumes of data, a huge amount of resources and processing and GPUs, which you need to then execute the building of knowledge graphs or in general building of RAG and search on RAG. That can be quite expensive. So I think also enterprise use cases are a great place where the benefit cost trade-off makes a lot of sense. If you're just doing like this for a general consumer system, you don't want everyone, just firing off queries randomly unless you have a huge amount of capital like OpenAI.
Right.
But if you're in a corporate system where it's customers doing queries and they're solving business problems, then it makes a lot of sense that, I can, pay the token fees and everything, but then it's saving me and my customers time and money because we're able to get answers faster and easier than we would if we were going through a human workforce.
That makes sense. And so just kind of one last question on the theme of ML ops. If someone wants to, go into the ML ops kind of profession, what is your kind of best advice for them? Let's say they are, they're just finishing high school and they have a choice between, getting a 4-year degree, going into a boot camp, Should they try and get a degree really kind of specific on IT ops, or just a general computer science, or even a general math degree? How do you feel like folks should kind of navigate that?
Yeah, no, I think that there's a lot of great options for like technology degrees. Despite what folks say, including Shlomi Benheim in the keynote today at SwampUp, developer jobs aren't at risk. Like, I think that AI technology continues to build and create new opportunities and new technical challenges that you need really smart people to solve. And my best advice for folks would be the real skill set you need to learn in college is how to solve hard problems.
Yeah.
And so if you feel challenged, if you're in a degree program, or if you're taking something where you feel like you're learning new material, you're like able to use your expertise to solve problems, to reason about things, to make a difference. That skill set, the ability to understand, pick up a new challenge, reason about it. LMs don't reason, humans do.
Right. Yeah.
And actually come up with some creative solutions. That's what's going to be the valuable skill set going forward. And maybe we're not going to be like sitting there and like coding basic algorithms for doing list sorting and all that stuff in the future. I mean, hopefully people aren't doing that, other than like programming 101, because machines are better at that and they're better at optimizing those things than we are.
Right.
But hopefully we're the ones who are actually taking the real world problems, figuring out how to solve the hard problems. And actually, MLOps is a great example of this, because figuring out how to observe, how to secure, and how to make sure that machine learning models are being taken from the developer all the way through to production is a hard problem. And a machine isn't going to solve this for us. This is something which you need people who understand the problem, they understand the space, they can do it. Actually, even my talk here at SwampUp is about using one of the tools in that toolchain, Artifactory, which you can use as a model repository, pulling information out of it, feeding it into a knowledge graph using the Neo4j knowledge graph builder. And in a couple hours on a weekend or an afternoon, you can basically have your own LLM with enterprise information from your machine learning pipeline, and then starting asking it questions like, which dependencies have an MIT license on them, or like what library, what's the latest version of this library? Like, you can start asking your own little system these questions.
Cool.
So I think that it's an exciting time for folks who are in technology professions, because if you're able to learn to reason and to create and understand kind of new problems and new challenges, then you'll have pretty much work no matter what field or degree program you go into.
That is great advice, Stephen. Yeah, I think spot on. Totally agree. Cool. It's awesome having you here at SwampUp here in Austin, and I look forward to chatting with you later on. Thank you so much for entertaining the folks here.
Yeah, no, thanks for having me on the show, and I'd love to join the discussion on Discord as well.
Cool, that would be great. We'll look forward to it.